Hey everyone, and welcome to the first event of the Monthly Dev. Woo! The Monthly Dev is a series of monthly online events where we bring world-class speakers to teach and inspire us all. We organize these events to create a TED-like platform for us, for developers. Especially during the pandemic, where everyone stays at home, it's super important to keep the gathering going, to talk to each other and communicate. I'm Ido from daily.dev, and I'm super excited to host you all here. What an awesome event it's going to be. For those of you who don't know daily.dev, it's a platform that gathers all the programming news in one place. I encourage you to try it out after the event. One last thing before we start, we promised a surprise, so here it is. Today we will be giving away 100 packs of stickers. You heard me right, 100 packs. And all you have to do in order to get these stickers is to share us on social media and make sure all your friends are coming. We will send out a sticker for the most creative shares. Just make sure to add the monthly dev hashtag and leave your DMs open so we can reach you out. And without further ado, let's get this event going and start with our first speaker for today. Please welcome on stage, David. David is a core team member of RedwoodJS, and he will get you started with this incredible new framework. Feel free to share any question during his talk in the comments. We will do the best to answer them all. David, the stage is yours.
All right, fantastic. Hey, just let you know if there's anything coming through my audio, Ido, please let me know, but I'm really excited to be here. Thank you so much, and thanks for a great kickoff. So Daily Dev, let's get this party started. I'm really excited to introduce you to RedwoodJS. And we're going to take you through a getting started guide. If there's any questions you have after this presentation is done, I'll be posting the links to the slide on Twitter. You can find me at the David Price. RedwoodJS is also on Twitter. And yes, that's my fancy photo because that's a reminder of the last haircut I had in a time when we used to put on clothes and go outside and hang out with people. So one day we'll get to do that again. Anyway, let's dive in. If I want to help you get started with RedwoodJS, there's a few things I need to make sure that I can do. I need to answer some questions about why there's a new JavaScript framework in this crazy JavaScript ecosystem and what it's trying to do. I really hope I get you inspired. There's a lot of things we could deep dive on. I'm going to go fast through a demo, but what I want you to take away is that there's something magical happening with Redwood in terms of the experience you get. And I hope you are inspired to take it for a test drive. And I'll walk you through the next steps to get started. We have a wonderful tutorial that gets you set up, shows you the prerequisites, and takes you through a lot of things you'll get to learn. I'll tell you what those are so that you can be successful with Redwood and join the Redwood community, because that's another really important part about getting started. All right. If there's any questions coming through, Ido's going to be grabbing those along the way as we go. Hope to have some discussion here at the end. And also, if there's anything where I get off track, Ido might jump in and stop me too. So don't hesitate to ask any technical how-to questions as I get going. Sound good? All right, let's do this. I'm excited. Okay, need to start with a story. It's going to be brief. But back in about 2017, so once upon a time, there was a gentleman named Tom Preston Warner. Tom was the creator of Jekyll, which one of the early, really successful static site generators, because it became GitHub Pages. And Tom was also the co-founder, one of the co-founders at GitHub. And Tom started to have some questions around, oh man, I want to build a modern application, and why is it so hard? He was a co-founder at another company called Chatterbug. He met a gentleman named Peter Pistorius, and along came, this was back in 2017, 2018. Later on, a gentleman named Rob Cameron, and then myself came along, and we had all these questions about what it meant to create a modern web application. We wanted to talk about conventions that made it easy and long-term maintainable. We needed a DB if it was going to be a full stack application, a modern UI. Tom has this thing he calls a universal deployment machine. I just want to push to GitHub and I want it to work and deploy everywhere it needs to be. We wanted an API that did everything, served all the clients. integrated with other services, and we wanted an end-to-end DX. So a developer experience from the start to the finish and long-term that achieved happiness as well as long-term maintainability. So not the right place to go. What we ended up doing was, I lost the slide. We had all these components that we found that met some of these needs. Okay, we found React, we found Prisma, Jest, GraphQL and Apollo and Storybook. And here's the thing about the JavaScript ecosystem. I know you're looking at this slide and you're thinking, okay, you're already doing it again to me, JavaScript. You're giving me a whole bunch of options. It seems really cluttered and messy. And by the way, I wish it was Vue instead of React, but that's not the point, because you see those little orange dashes in between everything. That's what makes JavaScript hard today. Sure, React is stable. It does a lot of nice things with UI rendering, and there's other things you could use. Svelte is hot right now. Vue is very much rightly loved, but okay, React is good enough. And we have these other tools out there like Jest and Storybook, but they take so much time to piece together. And GraphQL is a really powerful API, and Apollo does a really nice job with it, or GraphQL way of handling data on the front end and the back end. So not just your API, but your web service side. But what is complicated and what makes JavaScript developers' world and life painful is integration, configuration, Babel, Webpack. I kid you not, it took us about 6 months to get Jest and Storybook working with this framework so that we could have an end-to-end developer experience, but it needed to work across the API and the web. And we need to be able to mock data and set up a test database. And that's not what anyone wants to do when they start using a framework. So that's what RedwoodJS does for you. It takes the complexity out of configuring and integrating everything so that you can start to focus on writing application business logic and also learning the pieces you need to know as you go. So RedwoodJS is an opinionated full stack JavaScript framework that deploys to the edge. We've made some decisions about conventions. It has an API that's first class, database integration that's first class. Yes, it's JavaScript, so it has Node, React. It's a framework. It's fully integrated and it deploys to the edge. So that means it's meant to be deployed out of the box to Jamstack-like providers or Jamstack providers like Netlify, like Vercel. You could host it your own, but we're intending the infrastructure for this to live on to be the infrastructure of the future, which we believe is serverless. And by the way, when these things work together, it actually makes you happy and it's pleasurable to use. And that's what's fun about Redwood. Is it working? Well, it's less than 1 year, and here's all the milestones that we've achieved. And by we, I mean a community of over 1,000 members, more than 150 contributors. We've had not quite 1,000 people, but getting close come to our RedwoodJS meetup so far, and funded startups. We've won an award. It's been really fun. This is my favorite part of the fun. Hamish Irving, this was on our forums. I have not met him. We've interacted on the forums. And here's what he says. A testament to the framework, the tutorial, the docs, and the community that I've been able to build something with only a bit of front-end experience. Hats off to the team. And we want everyone, regardless of if you have decades of experience as a developer or you're currently in a boot camp or in school studying a CS degree, we want everyone to feel this way when they use a framework, because that gets you excited and that gives you the motivation, the purpose to continue on and learn. So that's why we think it's working. All right, time to do a demo. This is going to be super fast, assuming things don't break. I want you to focus on the concepts of what I do and don't worry about the deep dive and figuring out the technical details. I'll make one side aside to talk about data, but just look at the high level, because what I want you to do next is I want you to go start the Redwood tutorial, which will walk you through everything I walk through. You'll just have the knowledge you need to know about understanding where the bits and pieces come to make the framework work. So in the tutorial, you'll know ahead of time what people are talking about. All right, so into the demo, and you can see that we're starting off really well here. Okay, so the first thing I want to show you is a Redwood project. And while I get this set up, now don't mind the man behind the curtain. I have one thing I want to do over here, and I'll explain this in just a second. Okay, so the first thing I want to talk about is just what a Redwood project looks like. And Ito, if the screen size here is too small, please let me know. Just pop in and I can make it a little bit larger. I'm assuming everyone can see this. But this is a Redwood project. I use VS Code, and we're using Yarn workspaces. So in a mono repo, we have an API with a DB and this source file with things I'll talk about later, a web directory. This is where all the React magic is happening, and all these other things that most people ignore, but that's all the config craziness and all the integration essentials you need to run your project. There's some cool things happening in this Redwood outline. There's an IDE for Redwood, and Redwood loves the command line. That's where you're going to spend a lot of time working in Redwood. And this is a terminal that I've opened up right here. So I've already run the Redwood client, and let's take a look at what a Redwood app can look like. See if I fix that error problem. Here we go. So this is a Redwood blog project. When you start the tutorial, you'll be creating a blog. And in a blog, you want to be able to create posts. So this is what you're going to build in the tutorial. It won't look quite as nice. That's the start of the tutorial part 2, which was just released 2 weeks ago. And you want to be able to create content. This is actually plugged into a database. I'll save the rocket for the next line, right? So we're talking to a local SQLite database, and we are creating content. It's saved in the database. We can look at it. We can edit and delete it. Let's create one more post. And typing and talking. Slower than the first, right? See, I had to actually think about that one, right? Cool. And then these posts are coming through on the front end. So that's the Redwood project you'd be creating. We have an about page. You'll learn about forms. But most importantly, here's a blog site. It's got a list of blogs and blogs in it. Now, here's where Redwood starts to really help you out. I want to show you something right here called Redwood generators. So I'm at the command line, and I would run yarn redwood command, generate page. Let's just do a new page. And running that command is going to create the code and any other boilerplate I need to make that work. So let's see what happened here. We have a new page. It successfully wrote this. We have some other fun file types here. Stories, ingest, test, which I talked about. But let's just go to this page and see what, oh, that's right. I got this. I got it. New page. And this is a React component. There's a few fancy things that Redwood is doing, but we just have a React component right out of the box. And then we also have this routes file, and you'll notice it running that generator. This is a flat routes file, so you can see all the routes, path, page name, separated to make it easier to work with. And we already have a new page in our path. So the Redwood generators did all that for us. And I haven't done any layout, so I haven't used React to nest this inside of a layout, but here's our page, right? So that's kind of fun. I don't even know what React is. Actually, I had not worked much with React. I've been an Angular guy, and I hadn't worked much with GraphQL. And here I am writing code using the command line. So let's get a little bit more, let's have a little bit more fun here. And I want to do something that I'm going to do it first, and then I want to tell you what I did afterward. But okay, I've got these posts, right? And in my posts, I noticed something. I don't have an author in these posts. So the next thing that I want to do is I want to add an author to my post. But okay, I went to that UI where I updated all the, I created, I updated, I deleted. Well, that's a lot of components I did there. And I've got to have a database, so I need a table. Okay, there's a lot going on when you start to work with data. Oh yeah, and I want to render it correctly with React in the front end. So the first thing I'll need to do is actually want to model my DB. Remember I mentioned that thing called Prisma? I'll talk about this a bit more in a second, but Prisma is what helps us work with a database. It lets us tell the database what structure we want it to have, the database model. And it also lets us work locally. I create a migration, a snapshot of a database. I can set up a local database, save all of that when I'm ready to go, and then I can deploy it in one step. So that's what Prisma does for us. It allows me to use a GraphQL API to query and talk to a database. And it does a lot of other fancy things, including manage that process so I can deploy. But here's my database schema.prisma file. And I want to add an author field. So I just want there to be this field that's an author. And I want to be able to make that exist in my UI. And I also want to give it a default value. Right. And okay, so that's great. I just did that in code. I set up and told my database what I want it to look like. But that's not good enough. Now I need to apply that. So there's a few commands you'd learn in the tutorial. RW is short for Redwood. DB, if you can see these down here, DB save. I'm going to take that database model and I'm now applying it. It's called creating a migration to my local database, and I can apply this to production. And then I create a snapshot of what I want it to be. Sorry. And then I'm now applying it with the Redwood DB up command. So I've created a model. I've said, take a snapshot of that and now apply it to my local database. All right. Again, I haven't opened up any fancy tooling to work with my database. I have simply made some changes into a file and then run a few commands at the command line. But you'll notice there's no changes over here. And if I go to my post page, this is where I manage my posts. I'm also not seeing any changes here. Okay, well, it's because I didn't actually update the UI. So here we go. Here's the fun part. Redwood has a command for that. So yarn redwood generate G scaffold post, and I'm going to force that. What I want you to look at right here is not all the code that's generated, but I want you to imagine that those were all files that you yourself would have had to go through and handle yourself. And Redwood just handled all of that for me. And now magically on this page, I have the author anonymous field. I can edit it, update it, right? It needs to be the David, save it, and all of my UI is working. Okay, so hopefully that feels a little bit like magic. And how are we doing on time? We're doing good. I won't get to show you. Okay,
David, one quick question from the audience.
Do it.
Is Redwood based on top of Prisma 1 or Prisma 2?
Great question. We're using Prisma 2, and we've been using it from the very beginning. That's a great question. So let's spend a little more time. I'm looking at the time. I wanted to show you all how quickly I could do authentication, but instead I want to show you a little bit more time about how Redwood works with data. So here we have ID, title, author, body. And what I want to show you is in the GraphQL query, this is going to be small down here, but this is the web client sending a request, getting back data from the API. And I wanted you to see that this is the GraphQL response, the shape of the data. And the main important part here is that this data that was returned from the API is exactly this data here from the database model, which was right here in the post, right? All these are the same. And even more so, I mentioned I'd show you where Redwood works with data. Redwood does some really nice things, and it shows you how in the tutorial to work with the database logic. First, you'll need to set up your SDL for GraphQL. That's a schema definition language. And look, this is what we've created in our API to define what a post is, same fields. And then in our services, which is where all of our business logic lives, we have different queries. Remember I mentioned that we had a way to query our database with Prisma. This DB, that's actually a Prisma client object. A lot of information really fast, but what I wanted to show you is we have this request right here to find a post by the ID. And all of this happened through my generator. The generators are not only doing the heavy lifting for me, but they're also teaching me how these things work. And then there's a few other things I would need to do, and I'll show you that really quickly to get all of this to work and play nice with React. Because you'll notice if I go to the front here, right, there's no updates that have happened yet. And Redwood has a really nice way of working with cells. I'll take a timeout, and this is the next thing I want to show you. I will upload these slides and post a link from my Twitter account, but here's how Redwood works with data. And you don't need to understand all the configuration aspects. I just want you to see the parts. There's a DB that talks to an API, or an API that talks to a DB that talks to a client. That API can talk to any other API that you want. You only need one API. It happens to live on AWS Lambda. And Prisma and GraphQL plus Apollo are what's happening there on the, quote, backend. Apollo is optional, but there's a GraphQL working on the client side as well as React. And where all these things are happening in your project, if you look down at the very bottom, so that's the API directory, is your DB schema.prisma. That relates to Prisma. Your services.js, your GraphQL.SDL. So all your SDLs, that relates to the GraphQL, Apollo, and all your business logic in the API directory. And in the web, there's this wonderful Redwood invention called cells. And I want to show you what a cell is right now to handle your data lifecycle from React, which can be notoriously hard. I want to show you a blog post cell, which was created with my generator. Post ID title. So you'll notice right here, actually, let's go to this page again. I want to show you this GraphQL return. Hard to see, but you'll notice that there's nothing returned here for an author. If I refresh that, get the GraphQL, there's no author. If I add author here, save that, this page is refreshed. I'll see that GraphQL query, and there we are. Author's already automatically added. This is a Redwood cell. And in one React higher order component, all the heavy lifting has been done for you to query the data, manage the data, and all the states, loading, empty, failure, and success. And all that came out of the box with Redwood. And again, I don't want you to understand everything I just did. I simply wanted to show you how simple it is to do these things in Redwood because of integration and configuration. You can use these cell components at any level in your React tree. I would go into the component that is the layout. Sorry, not the layout, that's rendering the HTML for a post. Quickly, let's add the author, post author. Notice I don't have to do anything to handle props. There's nothing special because Redwood knows where the props are coming from, and it handles that for me automatically. If I save that and go back, I already have the David right there. Let me see if I can quickly go through. I've got 2 more places to update this, right? This is all the coding that I have to do. I already pulled that one up. Blog posts. It's fun to watch me type. Title, author. And if I do that and save it, now you'll see that if I go back to the home page, I now have the author on every post. And that's the magic of RedwoodJS and integration. You can learn React with RedwoodJS. You can learn GraphQL with RedwoodJS. All right, Ido, do I have about 2 more minutes to set up a couple of things, or is it a good time for questions? I had a couple closing slides, but I'd also love to show how to deploy, which I could do and run while we do some questions.
So we have some questions. So would you like to take them first and then go up to the closing slides?
Yeah, let's do that. So while we're setting, let me set up one more. One more thing. Let's take the closing questions. So I am setting up a deploy to Netlify, and I've done some work before. I'm running a command that's yarn redwood generate deploy Netlify. This is going to it's going to modify a file and create a file, but effectively it gives me all the config that I need to do a Netlify deploy. All these commits and changes I just made, we're going to stage all those. We'll commit them. And with one git push, that's it. All I'm doing is committing my changes and pushing to my GitHub repository. With one git push, I have now triggered deploy to Netlify. And I'm going to prove it. We'll try here. This is my deployed application. All right, living out on the web. And okay, yes, I do. Actually, I think I did everything right. So we're going to come back at the end and see if my deploy worked. And what we should see is that the author field should update here, and we can go and edit them. All right. Okay, Ido, yes, please. What were some? We don't want to see that. What were some questions that we had? And then I have 2 more slides.
So first question: what does opinionated mean in a framework?
Yeah, opinionated simply means we had to make some choices around the conventions we would use to name things, to structure things. So for example, we chose React, right? And we chose to support React first class, and we're not doing every possible front end that will be extensible in the future, but we had to make a choice to integrate and configure well. We chose to name things and we chose conventions, right? So blog post cell and blog post cell, but the reason, like with the S there at the end, and we also chose structure of naming things in a directory. And the reason we did all that is so your routes file just works, is so cells and all of your data lifecycle just works. And you don't have to figure out how to make your data flow from your database to your front end and back again, because Redwood has already done all that for you because we made opinionated choices.
So follow-up question to this question about opinionated. So is Vue or Angular is supported by Maximilian?
No, they are not yet. And again, those are excellent frameworks, and they do front end. They have their own special sauce and areas where they excel at front end rendering. But what we were looking for was good enough, an ecosystem with a lot of great tooling. And honestly, we didn't want you to have to learn React or Vue or Angular. We wanted you to learn how to manage your layout and your UI elements and components and write what you wanted to as simply as you could. And React was a good enough place for us to start that. Yeah, we can talk on Twitter about future support we'll have for other front end rendering frameworks, but for now it's just React.
Perfect. So you can check out David's Twitter handle and later on keep the communication going there. One last question before the wrap up. How good is the TypeScript support?
That's an excellent question. So as I didn't mention this, we're not even a year old, and version 1 is coming in the next few months. Redwood was started over 2 years ago, and let's just say the TypeScript community was not quite as vocal about the support yet. So Redwood started in JavaScript. We are about 75% of the way in TypeScript support. And by version 1, we will have full TypeScript support in your project with Redwood. You could install with TypeScript, or you could set up in JavaScript. And another heavily demanded feature that's coming out in version 1, and actually in the next few weeks, will be being able to pre-render pages, so marketing pages, product pages at build time.
Wow,
and that's coming to version 1 as well. Yeah, we have a lot of cool things coming in the long-term roadmap to make Redwood apps perform really well at scale.
So we have a few more questions, but we ran out of time. So make sure to post the questions on Twitter, and I'm sure David will be happy to answer them all. You have 1 minute to wrap up. And
awesome.
We can continue.
I would be. And actually, I want to encourage you. It's get started time. I hope you saw enough and got excited about not understanding everything I did, but got excited about the superpowers you might be able to have when you try out Redwood. So go to the tutorial. The tutorial is the place to get started with Redwood. Part 1 of the tutorial will cover everything I did with generators, React forms, data and DB, authentication, deployment. And I promise you, regardless of your level or familiarity with any of these technologies, you will complete the tutorial and feel like you have superpowers. And tutorial part 2 goes further into the DX of Redwood. You really learn about testing and Storybook. I didn't get to show you, but authentication takes about 5 minutes to set up. Testing in Storybook is just built in. I can run tests that I already have when the boilerplate code is run that pass. Storybook just works out of the box, and you can mock data. There's advanced data models in RBAC, and getting started is as much about joining the community as it is diving into the code. Please, we have a vibrant, helpful community that would love to answer your questions, help get you started, and if you want to, help you build your project. So lastly, we have stickers. This is our lure to get you to come to our website, redwoodjs.com stickers. We will send them for free to anyone, anywhere in the world. Please try us. There's no catch. We will send you stickers. Just fill out the form. Our next meetup is February 11th. You can follow RedwoodJS to learn about that. And I will post a link to these slides on Twitter here in the next hour or so. And that's a great place to follow up with questions for me, as well as find me on the forums or the chat. Ido, it was a pleasure. My only regret is I had so many things I wanted to show everyone, but way to go, Daily Dev, kicking this off. And thank you for letting me help start the fire to get these going. So really a pleasure.
Thank you. Thank you very much, David, for your talk. I personally can't wait to try out RedwoodJS. It looks so awesome and can't wait to see the future plans. So thank you very much.
You're welcome.
Coming up next is Sam from Google. He will give you his best tips and insights on how to ace a job interview. I encourage you to share your question as you did before, so we can have a live discussion here and Sam can share from his experience. Sam, I hope you're ready. Take it from here.
Thanks, Ido. Thanks, David, for the overview of Redwood. Very interesting stuff. Be sure to check that out after this talk is over. So hello, everyone. I'm Sam, and today I would love to run you through a talk and something I've been working on for a while and thinking about for a while, specifically navigating the technical interview. So for today's talk, I want to run through a few different aspects. First, I want to give you an overview of the scope of this talk. What are we going to cover? What are we not going to cover? Next, I want to step into the roles and responsibilities during the technical interview. Who is the interviewee? Who is the interviewer? What is each party trying to get out of the interview? Next, we'll go into the different formats that most technical interviews typically have. Then we'll go into explaining what a rubric for the evaluation of your success as the candidate looks like during the interview. And we can talk about each stage there and how you can be the most successful in the evaluation phase of the interview. Then I want to talk a little bit about the approach and the part that I'm really passionate about and really have thought a lot about, which is how can you as the interviewer, or sorry, as the interviewee, be successful as you go through the problem-solving phase and the interview phase? How can you navigate the rubric, and how can you correctly answer the questions and manage your time in order to be very successful? And then finally, we'll do a little bit of a wrap-up. So that is the plan for today. And as with the previous talk, please leave your comments in the chat thread on YouTube, and we'll be sure to answer them during this talk. I'd love a lively discussion and to kind of steer this conversation in a way that can help you in any questions that you may have. So to start, I'd love to go through the scope of this talk. So overall, this talk is going to explore how to navigate the technical aspects of the interview, which for many of us, myself included, is the most stressful part of the process of seeking a new job. Specifically, this talk is for software engineering position interviews. This is a write-up of my own personal experience during interviewing, and it's not a reflection of my current employer or my current role at my job. This is my own opinion and my own impression of the setup for high-tech interviews. I recognize that the technical part of the interview is only a small part of the entire process, and I recommend before going into any interview situation that you focus not only on the technical side, but also the non-technical aspects of the interview as well. That said, for this piece, I'm going to focus on what was, for me, the most stressful and ambiguous part of interviewing at a high-tech company, the technical interview. Much has been said about navigating the technical aspects of cracking the coding interview, diving into questions that you'll be asked and how you should be familiar with concepts like arrays, maps, hash tables, etc. Again, though, that's not exactly what I want to explore in this case. Rather, I'm going to go into everything except for the coding part of the interview. The surrounding bits that from externals may seem as the least important, but in my experience are actually very important parts of the interview. So to start, I want to clarify roles and responsibilities during the interview. So it's important that we clarify the roles and responsibilities of the technical interview process so that we have shared footing, a shared understanding of where we're going. By understanding the motivations and the goals of each of the parties involved, the interviewer and the interviewee, it will hopefully help to empower you to move through the process with a little bit more ease and a little bit more confidence. So the who. Who is the interviewer? Interviewer in technical interviews is typically looking to gather data. Data about how you do in technically challenging situations with arbitrary constraints applied to you. While true that the technical interviewer comes with some constraints that you do not typically have in real-world situations, such as writing on a whiteboard, not typing in an IDE, it's still a relatively well-known system of constraints that you can prepare for. And that's the key, that you can prepare for. Typically, the interviewer is part of a suite of interviewers that are going to be gathering overlapping signals during the interview phase for you that will be then combined and decided upon either by a collection of the interviewers or by the hiring manager. At the end of the technical phase of the interview, the ideal outcome, whether hire or not, is for data to be collected about your ability, you as the interviewee, to deal with the problems posed. More about specifically what you were able to successfully navigate and what you were not. And so the key is that multiple interviewers are going to gather these overlapping signals, combine them after the fact, and determine how you did, where your strengths and weaknesses are, and if they should move forward with a hire or no hire decision. So you as the interviewee are responsible for answering questions and for working with the interviewer to shape your own experience and the problem that you're solving. And that's the key, that you're working with the interviewer. It's not this antagonistic relationship. It's a partnership. Think of the interviewer as a partner with you who may not give you all the answers to all the questions that they ask, but will help you. They will provide hints. They will answer your questions, or at least a subset of your questions. So don't think that you're in this alone. All right, so now we understand the roles. So what do the interviews typically look like? What is the shape of an interview? What path does it classically take? So while not all interviews are the same, most do loosely follow these following patterns. They're roughly between 30 and 60 minutes, with the average being around 45 minutes. And the key here is to be prepared for the different situations that I'm about to outline. It's unlikely that your recruiter or the person that's setting up the interviews will know exactly what format each interview is going to take, but they should be able to give you some hints or direction. Additionally, when you start an interview, you can ask the person who's giving you the interview, what format does this interview take? Which can help you be better prepared to manage your time. The first one, I'm calling this the middle of the road. Typically, there's about 5 minutes at the start, meet and greet, hello, how are you? Do you need to use the restroom, etc. Then between 5 and 10 minutes for a warm-up problem. Sometimes this warm-up problem will lead into a larger problem that the rest of the time is allocated for. Sometimes, though, it's just a simple one-off question, just to get your brain going, to get you warmed up. Then there's roughly 25 minutes that are reserved for a deep technical problem that you will spend the majority of your time solving, and then finally 5 minutes at the end. So in this phase, you roughly have 30 to 35 minutes to actually solve the technical problem, which doesn't leave you a lot of time. The second one, and this is what I typically see in longer interviews or later in the day interviews, is you have your meet and greet, and then right off the bat, you go into a deep technical problem solving phase. 35 minutes to go through the entire problem. This is usually heads down time for you, and they're really pushing you on the technical or problem solving aspects of your skill set. So the interview rubric. Like it or not, your success in an interview is most likely going to be fit into a rubric of sorts, not a pass-fail Boolean that we as engineers kind of like to evaluate things by, rather a fuzzy, noisy signal that is going to be applied across multiple dimensions and multiple criteria. So herein lies the common misconception with technical interviews. Your passing or failing the interview is not exclusively about how well you're able to formulate the technical solution to the prompt. It's how you deal with the constraints that you are given to work with. It's how well you're able to approach the problem and navigate the problem space. Most rubrics evaluate your success based roughly on the following points. But I just want to stress that getting the correct technical solution is not always and doesn't dominate the evaluation for whether or not you pass or fail. So the first part of the rubric that I see is your ability to communicate your thought process effectively. This is all about how you can communicate what you're thinking, your thought process, and your approach. This is unrelated to the correct or incorrectness of the final solution, but rather your ability to speak in a way that your interviewer can follow. Silence is not really an option when solving a problem during these technical interviews. This evaluation criteria is based on the common concept that in most engineering organizations, communication dominates a significant portion of your job. It doesn't matter how brilliant your technical solutions are. If you're unable to communicate with others as you explore the problem and document your findings, it'll be difficult for you to integrate well within an engineering organization. And this is the key. So they're evaluating how well you can speak and speak to what you're thinking.
Sam, we have a few questions from the audience.
Sure, let's go for it.
So first one is, does degree matter to get a job interview?
So coming from myself, who does not have a technical degree at all, actually has a degree in photography, no, a technical degree does not. Sometimes early on in the recruiting process, they'll use a degree as screening criteria, but that's easily overcome through communication and kind of a strong portfolio.
Thank you. And we have another question. How much whiteboard interviews matter currently?
So, yeah, great question. And I want to stress a point that I didn't point out as strongly as I would like to. This in no way is meant to be a defense of the whiteboard interview. This talk is more just a reflection of what I've seen in the industry. So I still do see the whiteboard interview where a whiteboard may be in person on a board or remotely in a text document. So solving problems is definitely still technical problems, and demonstrating your ability to program is definitely part of the evaluation criteria.
Yeah, and whiteboard is an integral part of it, right?
Yeah, the whiteboard as an implementation detail.
Yeah, I see. Okay, thank you very much.
Definitely. Okay, cool. So the next part of the evaluation criteria is your ability to deal with ambiguity. How well are you able, when given a vague and underdefined problem, to deal with this lack of clarity? In technical situations, it's rare when you're provided both with the problem and the exact correct solution. Often you're given a partial or vague problem statement with some sort of proposed solution. Your ability to turn this lack of definition into a concrete problem and successful solution is critical, and something that is very rooted in reality. For some organizations, this will be more important than others, but for me personally, if an organization doesn't value this sort of problem solving and deals with ambiguity value, it's not a super rewarding job for me. So it's a little bit of a two split evaluation for you as the interviewer and as the interviewee. Next is, how well can you express yourself in code? This is all about how well you can turn high-level thoughts into code. This is one of the more baseline requirements, and as we just talked about, the whiteboard aspect, where it's your ability to translate your thoughts into programming, into valid syntax for some language. This is going to be a critical part of your job if you're interviewing for a software engineering role. Next, and this is the part that we all dread, is your ability to arrive at a working solution. So are you able during the interview to arrive at a solution that works, where for many cases work is defined as either test cases provided by you or by the interviewer during the dealing with ambiguity phase of the interview. While the section may seem the most binary pass or fail of all the sections, the rubric does have a sliding scale, as there are many ways to arrive at a partial working solution. In most cases, the evaluation criteria for you will take this into account. So don't let perfection prevent you from getting something down. It's totally fine if the optimal solution is not obvious, and for you to say, this is just going to be a brute force implementation because I can't think of the best solution. Once you have a working solution, even if it's a brute force solution, it's okay to build and iterate on that solution. But the key is to get something down. Next is the complexity or performance-aware solution. So to some of you, this may seem void of meaning and signal and more like a box that you have to check. However, let me challenge this perception a little bit. Being aware of the performance characteristics of a solution, and especially keeping them top of mind when designing a solution, is a sign of experience and technical design maturity. Often caring about performance and complexity is a skill that develops over time in engineers, and is a skill that develops due to experience with systems that weren't performant. So you're aware of it from the get-go because you know how hard it is to add performance back in. It's important and worth verbalizing the big O or performance or memory characteristics of your solution, because the interviewer most likely has a checkbox and they're most likely going to ask you, and you bringing it up just shows that you're thinking about it. All right, so now we sort of understand how the rubric works. Let's talk about how you can approach the solution and navigate it successfully.
So one question before you start. How to handle questions like salary expectations in a technical interview?
Definitely. So my recommendation for all the non-technical aspects of the interviewing process is to work with the recruiter. So whoever talks to you, whoever tries to get you to join, or when you apply, you send your resume, you'll get connected with someone, to have that conversation up front with them. Usually the technical interviews are not the place to have that conversation.
Okay, thank you very much.
All right, so into the approach of how you can deal with this rubric and the constraints of the interview. So how can you optimize to be judged for in the most positive way? So it comes down to you having a plan and working the plan during the interview. The experience of tech interviews has been so romanticized and dramatized in popular culture that it can seem like the expectation for the interview should be some sort of low, neon lit, transparent whiteboard, dramatic breakthrough experience for the interviewing candidate. But let me let you down on this. Good interviews are, for the most part, incredibly formulaic and boring, with the candidate following a plan through each phase of the interview. This isn't some kind of accident. This is the candidate recognizing the format and ensuring that they check and accomplish as many of the sub-goals in their rubric as possible to ensure the best outcome. So have a plan, work the plan. Every interview can follow your plan, and that's the key. The first is time, managing your time. Time is your enemy. There's a clock. There's a limited amount of time in order to complete the session. Taking too long in any one phase, regardless of your intention, can cause you to have a negative outcome, even though you're doing everything right. For each phase of the interview, set a bounding time box and move on if you're unable to make progress. A partial incorrect solution is always going to be better than nothing. Running out of time during the technical solving aspect of the problem is, to be fair, almost always expected. But it comes down to how much time you leave yourself to put a stake in the ground and show that you know what you're doing. Too often I see people getting stuck in the definition phase of the problem or pseudocode phase of the problem, leaving themselves under 10 minutes to start writing the actual solution, which puts them at a very strong disadvantage. The next part is the fungible problem, and this seems to be a little more unknown, and I wanted to pull the curtain back on this one. Understanding and defining the problem is critical to you to be able to come up with a solution that meets the goals that the interviewer wants. To rephrase, your interviewer will give you a vague and underdefined problem on purpose. It's not that they're a bad interviewer. It's that they're giving you a vague problem because they want to see what you do with it. So it's up to you to assume that the problem is not fully articulated or explained, and for you to push and pull on the requirements of the problem and to steer the problem into something that you want to solve. You can define bounds, you can define test cases, you can basically define how the problem is going to be solved and the requirements. And don't worry if you try and say, well, I'm just going to ignore this part of the problem. The interviewer will likely say, no, I don't want you to do that. Can you focus on this part? But you do have quite a bit of control. So don't be afraid to steer the interview based on what you want to do and what the time is going to allow you to do.
So quick question here. Are the technical questions generally just hacker-rank or leet code type of problems, or is there some type of building the scaffold of a program?
There will be a range of interviews typically. Some interviews will focus on architecture. So that's more the building the scaffolding. And some interviewers will ask you questions more like leak code or these sort the tree, filter the list kind of questions. So you'll get both.
Okay, thank you very much.
So I want to talk a little bit about pseudocode. So often it's tempting once you have the problem defined well enough to actually go into implementation and start writing syntax. But I really strongly caution this approach. Even if you know what you want to do, you are carrying assumptions with you as you go into the technical details. So I strongly recommend taking the time to write out a pseudocode implementation prior to writing syntax. Writing pseudocode is cheap and fast and will allow you to invent your own kind of simple syntax to express your intent to the interviewer. This approach also acts as an outstanding mechanism to run through test cases and communicate your intent to the interviewer. The important part to recognize is with pseudocode, it enables you to prototype in a way that is communication friendly and iteration friendly, where syntax usually is not, especially when you're dealing with a whiteboard. And I want to stress this point again. The interviewer is your partner in this. They're not your antagonist. They're not your enemy. The interviewer is not there to make the situation more difficult. They're there to test the bounds of your ability, but they're also there to help unstick you as well. If you get stuck on something like the syntax of a function, it's not going to provide a good signal to the interviewer if you just get stuck there. So ask questions. It's not a sign of weakness. They're there to help. This is similar to how the real day-to-day works in a business. You are in an interview, you're in a foreign situation solving a problem that you just heard N minutes ago. This is a fake constraint and a fake pressure situation. Your interviewer knows this, and they're there to help you deal with this situation. So in no way can you not ask for help. In no way can you not tweak the problem. Ask questions. The interviewers may not answer all the questions, but they should help you. And that's an important thing to realize going into these questions. The next part, and something that I see people getting caught up on a lot, is knowledge of APIs. Programming on a whiteboard or in a text file is not a real situation. Just want to stress that. Most of us are never going to have to do this on a daily basis or even a yearly basis. Most of us have trouble enough switching to new keyboards. It's a good idea to prepare for an interview by being familiar with the base level features of a language, but it's okay if you don't remember if it's the first or second argument of a reduce call that gets the current value or the accumulator. It's okay to call out during the interview, I'm not 100% sure what the API is of this function, but I'm going to assume that it works this way. And that's okay. That's a sign of your ability to create an abstraction and work with that abstraction. Rarely is your evaluation in an interview based on your ability to memorize APIs. That's just not a reflection of what the day-to-day job of a software engineer is. Taken further, you can, in the interview, define black boxes of code and say, I'm going to have a function called make button that's going to return a button. I'm not going to implement the string building or HTML building function. It's okay to do this. And if you do it too much and your interviewer says, oh no, don't do that, they'll say that. They'll say, don't do that. Say, okay, fine. So you implement that. You can break up the problem. You can focus on the interesting parts, and you can ignore the unimportant parts by creating abstractions, just like we do in our code. So in summary, technical interviewing is daunting and it's stressful. Absolutely. I'm not saying that it's not. Putting yourself out there to be evaluated against some opaque set of criteria by others in a position of power in order to get a job, for many of us, is not what we would call fun. You as a candidate are in a more powerful position than you may be aware, though. By understanding the roles and responsibilities of the interview, by creating a plan about how to handle the technical interview, and by working that plan over and over again during the interview, you can stack the deck in your favor and come out the other end of the interview process with offers. So with that, thanks so much for listening, and I'd love to hear any questions that you may have.
So we have another question. Does it matter the years of experience I have if I'm applying for an entry-level junior positions?
Yeah, great question. The interviews are going to always be scaled against kind of your level that you're being hired at, or the role that you're being hired into. So if you're someone out of college or someone that's new to programming, the interviews should reflect that, and the evaluation criteria should also reflect that.
Thank you. And I guess no more questions. Yeah, that's it. Yeah, so thank you very much, Sam. If you have any closing words, this is the time.
No, thanks so much for having me. Thanks so much, everyone, for listening. And please, if you have any questions, feel free to mention me online and ask away. Always here to help.
Thank you again. It was a great talk. I believe our audience here got themselves pretty good image of what a technical interview should look like and how to get prepared. So thank you very much. Our event is got to its end almost. So before we close, I would like to welcome our final speaker for today. Please welcome Ben. Ben is a core team member of RxJS, a reactive library for JavaScript. He will walk you through your first steps in reactive programming. Ben, let's do it.
Right. Sam had some great tips, by the way, for interviewing. I went through the interview process at Google as well. It's the other thing that I don't know if you mentioned this, but don't give up if you fail. That's I know a lot of really, really good engineers that failed their first Google interview. So, you know, if you really want to get in somewhere, keep trying.
Yeah, I think consistency is the key. Thank you.
Let me go ahead and share my screen. All right. Hopefully this is visible. And can everybody see this okay? Is it kind of weird or?
Yeah, it looks great. Thank you.
Okay, great. All right. So I'd like to talk a bit about reactive programming fundamentals, and I'm going to dive into some RxJS in a little bit, as I suppose that people would expect me to. Again, my name is Ben Lesh. I'm an engineer at Citadel, and I'm the RxJS lead. I was also at Google and Netflix prior to being at Citadel. At Google, I was on the Angular team. Reactive programming, there's this thing going around where everybody seems to think reactive programming is just about observables or just about RxJS or something of that nature. And it's not actually just observables. Reactive programming is a broader set of things. And really, it's about programming declaratively with special attention paid to the propagation of change. So the idea that you're going to have declarative pieces that see a change has happened and then react to it in some way. There's actually 4 major reactive algorithms. If you go to like the Wikipedia article for this, they say there's only 3. I am going to go ahead and say there's actually 4 because the 3 that Wikipedia will say, and a lot of other texts will say, would be push, pull, and then push, pull. But I submit to you that push pull is actually different than pull push. So I have another one listed in here, and I'm going to talk about what these are. Now, reactive push is the most common one that people think about. So this is where the consumer, which is the code that's saying, hey, I want to get values from this algorithm, this system, is given the value. It's pushed the value by a consumer. And this is generally done by giving it some sort of function like a callback, and the callback is called whenever the producer determines that it has a value to give you. The consumer shouldn't need to do anything additional to get the value that it needs from what it's been pushed. And this is important to call out when you compare to the other mechanisms. So examples of this are promises. We see that everywhere where you can do, you get a value from a promise, and then you do this, then you do this, then you do this, and so on. Observables are actually everywhere. It's not just RxJS. Svelte has their own observables. Relay has their own observables. GraphQL internally has observables. Like it's pretty common. And event emitters, and I have an asterisk there because it kind of just depends on how you use them. But again, these are pushing values at you, and there's a lot of other examples of this. Now, reactive pull-based, in this case, the consumer has to proactively say, I want this value. So generally, it has a method that it calls like a next that returns the value to you. And again, the consumer shouldn't have to do anything else to get the value that it needs after saying, give me this value. Examples of this are things like iterables. So an iterable is a type that exists in JavaScript. So like you can iterate over sets, you can iterate over arrays, you can iterate with generators, and you can actually get this by saying symbol.iterator and calling that as a function on any of these types. There's also in other languages, there's enumerables, or sometimes there's enumerables in JavaScript libraries. And there's things like computed properties. So computed properties, I have an asterisk there because really that's also kind of a push-pull sort of thing. But you could have computed properties over iterables, which kind of makes them iterables, but you know, and there's other types as well. Now, the third type is reactive push-pull, and this is one of the ones that actually is in, say, like Wikipedia articles and other academic articles on this. In this, what happens is the consumer sits there and listens for a notification from the producer. The producer says, hey, something's changed, but they don't tell you what's changed. And then, or maybe they tell you what's changed, but they don't tell you what the new value is. And then the consumer is then responsible for saying, okay, I'm willing to react to this change now. Give me the value so I can do something with it. So effectively, there's a push, which could come from something like a promise or an observable or anything like that, any sort of callback. And then there is a pull where they're pulling a value out of a method or an iterator or anything like that. And there's a lot of different examples for this, and they're all kind of mungy because, again, this is a more complicated mechanism. So things like Ember's object model or MobX, or there's some aspects of Vue that are arguably push-pull model.
Ben,
and a lot more. Yeah.
Quick interruption. People here ask if you can increase the size of the screen, if that's possible.
You know what it is I've got like one of those super ultra wide monitors. So
oh yeah,
I think that I think that it's going to be a problem. I'll just go through the slides here if that's more palatable. And
yeah, this looks better, much better.
Yeah, I don't have any fancy animations or anything, so it'll be fine.
Thank you.
So with reactive pull push, which is the other type that I've sort of added to this list. In this case, what happens is the consumer says, hey, I'm ready to start waiting for a new value from the producer. So it requests a future from the producer, like a promise or something like that. And then the producer says, oh, okay, well, I see my consumers waiting. And as soon as it gets a value to give to the consumer, or however many values the consumer requested, it then pushes those values at the consumer. So this is an important call out because it is different than the other case. The other case is the producer notifies you and then you pull it. This is the consumer says, hey, I'm ready. The producer notifies them, and then the producer notifies them of the new updated value. And when it gets that new value, it doesn't need to do anything else to figure out what's in that value. And an example of this actually exists natively in JavaScript, which is async iterators or async generators. So you can create these with like async function star. This is also kind of the crux. Async iterators are the crux of RxJS, which is a kind of sister library to RxJS. There's a lot of other examples to this. But the important thing is all of these are different, and all of them have specific use cases where they're good. And there's a lot of kind of mungy in between space where you could debate whether something was pull or push or push pull or pull push or whatever. But the basic concepts are there. And they all have different pros and cons. So pros to pull is it's really simple. It's totally synchronous, which makes it very easy to reason about. And the consumer controls the rate. So if your consumer is something that's busy rendering animations and all sorts of other stuff, it can be like, okay, now I want this value. And then it can do whatever busy thing it's doing. And then say, okay, now I want this value again. The cons to this is it doesn't really handle async well. So if you can only say, give me the method or give me the value right now, totally synchronously, the only way you could do something async would be you'd have to poll it and just say like, do I have the value now? Do I have the value now? Do I have the value now? And it would be not the best API for handling something like that. Next we have push. So push is again like RxJS. So this has some really good advantages. It's still pretty simple in that you just kind of subscribe and you get these callbacks that just push values at you. So promises are like this as well. It's got an advantage in the case of observables, or in the general sense, push reactive programming can be either asynchronous or synchronous. If it's a promise, it's forced asynchrony. I could get into a whole talk about why I don't like that, but with push-based reactive programming, it could be synchronous or asynchronous because the producer is telling you when it has the value, and if it has the value synchronously, then you get it. If it has the value later, then you get it then, and that's because again, the producer controls the rate. Now, the cost of this is the consumer has no real control over the rate of values at which it gets new values. So if the consumer is something that tends to get backed up and you get like back pressure problems, this isn't the best choice all the time, but you can still handle things. And then of course you've got the hybrid approaches, which are push-pull and pull-push, and they have their own issues, or bonuses and issues. So push-pull, again, could be synchronous or asynchronous. The producer and consumer are actually working together to control the rate, which is kind of nice. But it requires a lot more coordination than just pull or just push, because now both sides have a contract to kind of fulfill. And the same thing with this. It's literally the identical problem to push-pull. Is there's a contract you have to fulfill. But it has the same advantages where producer and consumer are kind of working together to control the rate. So both of these approaches are good for what's called back pressure. And again, like the hybrid approaches, they're good for high volume systems that have back pressure issues. So back pressure is something you're concerned about when you're like, oh, I don't want my thread to get overwhelmed trying to process this. I want to only go and get stuff when I need to. Handling it with these, the cost is some complexity, but like these approaches are great for that. One of the reasons you're not going to see this so much in a UI though is if you're trying to like max out your utilization of a thread in a server, that's great. That's probably what you wanted to do, but you probably don't want to max out your thread utilization in your UI because it will be unresponsive. So generally speaking, these approaches aren't quite as popular in the UI, despite being natively available in JavaScript. So if you ever want to know more about back pressure, or this kind of more detail about what I was talking about there's a great talk by my good friend Jay Phelps that I'll link here, and I'll make sure to post the slides all about back pressure. But now I want to get into actually like some live coding stuff, and I'm trying to be time sensitive, so hopefully I'll be able to get through a good chunk of this. What I want to do is just kind of show off a little bit of like reactive programming in RxJS and how you would go about reactive programming. The thing about reactive programming is it is supposed to, especially with push-based reactive programming, a la RxJS observables, you want to have this react to changes in whatever source of data it is. And you don't know where that data comes from. And so as an example, what I want to do is I think I'm going to make something where I can add numbers together. And I've already got a little bit of HTML here. I'm going to put some inputs in here later. Right now I've got this output tag, and I'm going to just go in here, and you can see like if I say, all right, output inner text equals test, that it's working. So we've got test there. Let's see if I make that any bigger. I'm going to maybe change the make sure everybody can see this. Better? No? Yay. All right. So that's a little bit better. This is how you should always style your stuff, by the way. I can clearly write something out there. And if I wanted to add two numbers, obviously the simplest thing would be like, okay, I'm adding 4.5, ta-da, and it'll just work. Now, TypeScript does not like the fact I'm setting this to a number, but clearly JavaScript's okay with it, or the browser is anyway. But if I wanted to do this from an observable, I would want to have some source observable that would be like, we'll just say it's the results. This is just some notation. You don't have to worry about this. I'm just doing this to kind of designate what's an observable and what's not. And we'll say the result is 9. And what we'll do is subscribe to result, or we get a value. We say output inner text equals value. Of all this really does is just create an observable that immediately synchronously emits a value. So if I was to put this in here and just be like, okay, so you get 1, then 2, then 3, it's going to write out 1, then 2, then 3, and it ends up with 3. And I can see that in here if I want. So it logs out 1, 2, 3, and 3 is the last one, so it kind of wins, right? Because it's doing it all synchronously. So what you want to do when you're doing reactive programming with push-based reactive programming, in my opinion, the best practice is to work your way backwards. So that the end result is we want to get a value that is our result of adding things together and stick it here. I also at some point want to add some inputs to this up here so I can get those values from some inputs, some HTML inputs, and put them here. But I'll get to that in a minute. Right now, I need to figure out how to actually add an arbitrary array of numbers together. So that means I'm going to have some like number sources, or at least a observable of arrays of numbers, right? So I would have to be like, okay, so maybe I've got an array of 1, 2, 3 is what I'm actually getting. And my results should be something where I'm taking those numbers and I'm going to pipe this through a map function. Now, map is made to transform value. So I'm going to take this, and this gives me our array of numbers. And inside of here, I'm just going to say let results equal 0 and then 4 of nums. Let's add that together, and I'll return the result. You know, it might even be cooler, actually, if I was to do nums, let's see, join. Something like that. So now we can actually see, and if I go in here and change this, so this step here is, add numbers and create display. Right. So now I'm able to take any source of numbers here, any at all, and put this in here. And one of the reasons this is kind of interesting is I could do, this could be any source. This could be, because it's just an observable of like arrays of numbers. This could be from a WebSocket. This could be from, mouse movements. This could be from literally anything. So it's kind of an interesting thing. I could do something where I take 3 clicks and add the X coordinates together or whatever I want, just so long as this is being fed an observable of arrays of numbers. So that brings us to the next thing. Okay, so how do we get an observable of arrays of numbers from some inputs? Well, for one thing, we're going to need some inputs. So I'm going to create a function that like creates inputs, or maybe I'll even have like an observable that creates, when you subscribe to it, adds an input to this as like a side effect. So I'm going to try that. I'm going to call this like add input. It's going to take like a ID string, new observable of HTML input element. That's what we actually care about. This is just like a mechanism for creating a new observable. Anything I call next on this will actually come out of my observable. So what I want to do in here is I'll say, okay, I'll just make like a div document create div. In my div, I'm going to set some inner HTML because this is the best way to code things if you don't have a framework to help you. And let's see, we got a label because we want, we care about our users. So we got a label for E. ID in there as the label. Input type equals number, ID is E. And I want to return div query selector input as. So this is now a function that returns, you give it an ID and it returns an observable of HTML input. Cool. But how do we use it to get this? Well, we have to get there. So let's just say that assuming that I've got some observable of input, let's just make one. Add input. Okay. Let's see. So there we got an observable of input element, and we want to get like an array of values out of that. We could say, all right, maybe we need more than one. I'm totally making this up as I go, just so you know. So we've got these two different things here. We need to get an array. I could do what's called a combine latest, where I can combine the latest value of two observables, but we still need to make these into observables of numbers. So maybe I take this and take this, and I have to cat map, which is a flattening operator. And I don't expect everyone to internalize all of the RxJS complexities that I'm adding in here. You would learn these things kind of eventually. Concat map is a flattening operator. So it takes an observable, gets the values from it, maps it into a new observable, and then flattens the observables values out into the outcome. So I'm going to take this and say, let's make sure I've imported it. Does not want to import, but it is imported. All right, so go in here, and here's my inputs, and I'm going to do from events inputs. Every time the input changes on input, so this is from input events on my input thing, I'm going to also want to map that values out as numbers. E target. What do I have here? Now I've got an observable of number. And actually, I'm going to have to do the exact same thing there. So I'm just going to copy and paste because I'm lazy. And this should be the same thing. Let's see, why doesn't it like this? Let me fix that for you, TypeScript. There, now TypeScript is happy. So these should be observable of numbers, which they are. And I need to combine them. We have this thing called combine latest. So to get my observable of numbers now, I can do combine latest. And combine latest will combine the latest values from two, from any array of inputs. So I'm just going to put these input a $E, $sign. And what's it have now? So we've got observable number and number. So we're in there, and what's going on? So it's not actually adding. I've got to clear my console in between. It's helping me. It's actually adding this in. Why is it not adding this in? It doesn't like subscriber is declared, but its value is never read. Oh, because I'm not actually emitting it. Silly me. I think I'm the author of this library. Subscriber next. And then I'm going to return whenever this tears down, we want it to remove that div. So we'll just do div.remove. Right. So now what do we have? So we've got this in there. Inputs. I'm not actually adding it to the input. That would be important too. Inputs. append. All right. So we've added A twice. This one's supposed to be B. Let's see what happens. If we get one value and we get, as long as we get one from each, there we've added them together. So that's pretty neat. We should probably have them each start with 0 though, so we get something right off the bat. So although it doesn't really have a value in there, so maybe we'll just leave that for now. But this is like, we're on our way, right? So now we're to the point where it's like, okay, well, we can combine this. So as long as we have an array of inputs we can put in there, what if we had an observable of an array of inputs? Like, how would we get to that? And to get to that, we're like, okay, all inputs equals of, and we just put this in input A, input B. So what if I want to dynamically add inputs to this? And we'll have to add a button to do that later. But so that means that if I have this, I'm going to need to take this and flatten it out with a switch map. We're still working, it seems. Let's see, let's test it out. Yep, looks pretty good. All right, so now I've got an observable of inputs, which means if I could make this dynamically be a list of inputs, then all of a sudden I've got something kind of cool. Like, so I can go in and I can add a button. Let's add a button here that is like button ID, add input. And we need to select that up here. Oh, it doesn't like that because there's a function of the same name. We'll just name this add input button then. And now I need to make it so this derives from somehow clicking that. So maybe I just go here and I say, all right, from events button, click that into here, and then we need to add something. Maybe let's see. Let's add input. It needs some sort of input. I'm just going to use the index or something as a value. It wants a string, so we'll just call this like there. And maybe I'll take that. But this needs to be an array still. Like if I just have this, and it is. This is just an observable of HTML input elements. So I need to build out an array of those. So I'm going to take all of that, and instead of doing this here, say, okay, let's build out an array by scanning. So scanning is like kind of a reducer sort of thing. And we're going to say, here's all inputs, this is the new input, and we're just going to say all inputs gets the new input added onto it. And it starts off with an array of nothing as so now this is the right thing again. So in theory, every time I hit this, there's one. Oh, it didn't add the second one. So I biffed something up there. That's not working either. All right. So let's look at this. Add input. I wouldn't need these anymore. So it should be an observable of arrays of inputs, which is what this was expecting. Let's Gives it. That's not our numbers though. That's because I didn't actually do this number conversion. There's your problem. Come on. So really I needed to do this whole bit inside of here instead of just add input.
So Ben, we are running out of time and we have a few
right.
questions. So can we proceed with the questions, or do you
Absolutely.
want? Okay. So first question from the audience: do you recommend to use RxJS with React? Which problems are solved by implementing it, or what its benefits?
Yeah, I mean, like it depends. Like, so first of all, I didn't. The next slide in this was basically going to tell you don't use RxJS to add numbers together. It's probably not the best use case for RxJS. Mostly, I was just looking at kind of a reactive programming solution and trying to work my way backwards through a problem just on the fly. But the RxJS's primary like wheelhouse is where you've got multiple streams of data, and it could be from user events like clicks and that sort of thing. But even better would be if you've got like WebSocket push or server sent events or something like that, because you can do things like, so at work, we've got issues where we've got multiple streams of data that need to be joined so they can be displayed in a table. And doing that is not easy to do when you've got, if you're just trying to do it with imperative code. It really, really isn't. Where Rx gives you this set of tools like with concat map and filter and all this other stuff, so you can use it similar to how you might use like a SQL programming language to query tables, just you're querying events. So yeah, you can use it anywhere. It's used more in Node actually even than most other places. And obviously Angular, React sees a lot of use for it. There's official support for it in Svelte and Vue. So you can use it pretty much anywhere.
Yeah. And another question is, what is the relation between, let's say, reactive programming and streams, or more correctly, observables? Yeah.
Oh, so this is so there's streams covers a big broad gamut of stuff. The relation between reactive programming and streams, you can do reactive programming with readable and writable streams. You can do it with node streams. You can do it with RxJS and observables and call them streams. Like they all deal with streams of data or streaming data, data pipelines, that sort of thing. So, I mean, I guess the relation is they're all reactive programming to some degree. One of the things I didn't actually get to in this, because I wasn't entirely sure how long I had for this talk today, was you can also mix mode things. So while observables push at you, inside of that push, you could also pull values. So you could use observables to do push pull. MobX does this. But again, this is all like semantics and debate. Like, how do I want to label these things? But I could have an observable that pushed at me, and then I would just say, okay, well, I know the state all exists in the DOM, so I can go get all the values off of all of the inputs that are already sitting there, right? Now it's push pull. So it's all reactive programming, as long as you are kind of blindly reacting to a source or something producing data and giving it to you, or producing notifications and giving it to you, and you pull the data out. The important bit is you don't have to know too much about the previous step in order to get that done. It's more declarative.
Yeah, I remember reactive programming from the days I programmed in Scala. It's very popular there, and I actually miss it a lot. So thank you very much, Ben, for this wonderful talk. You actually are a true hero, as you bravely live coded everything. It's highly appreciated. So thank you very much.
All right, thank you.
Bye-bye. So our event has got to its end. I would like to thank you all for joining our first event of the monthly dev. It wouldn't have been the same without all your comments and without seeing you here. So we are very much appreciate you dedicated the time to being here. As we mentioned in the beginning, we organized the monthly dev to create a TED-like platform for developers, for us. We try to give a place for speakers to talk, and even though we have the pandemic going on and everyone stays at home, we still try to do this gathering so we can talk to each other and get the communication running. We put so much effort in organizing these events, and we will very much appreciate if you can fill out the survey that we will share immediately after this event through the comments below and through your mailbox. We are about to close the lineup for the next event, so the registration is now open. We will share again the link in the comments and in the mail, so make sure to RSVP because we have tons of great speakers that are waiting to talk to you and teach us new things. So until then, see you next time. Thank you very much for joining.